Welcome to solverfy.
We have a chemical compound called menthol with a molar mass 156.3 gram per mole. So what would be the molecular formula? When we have our compound being undergo a combustion reaction, reacting with oxygen to produce carbon dioxide and water only. Okay, so first of all, we have to find out the number of moles of carbon and also number of moles of hydrogen and also the number of moles of oxygen. And then it will help us to help determine the molecular formula. Okay, so from here, how can we find out the number of moles of carbon? If we look at the combustion reaction over here, but keep in mind that this is not balanced. This is not balanced. So the carbon will be converted to carbon dioxide, and also the hydrogen will convert to hydrogen, water. Uh, and the oxygen, because we have to add like external source of oxygen, so it may not be helpful for us to find out the actual amount of oxygen by simply from CO2 and also water. But CO2 and water can help us to find out the number of mole of carbon and also hydrogen. Okay, so let's find out the number of mole of CO2 first. So number of mole of CO2 will equals to our 0.449 gram per mole divided by our molar mass of CO2. So it will be equals to 44 gram per mole. This is 44 gram per mole. So 0.449 divided by 44. So we have 0.0102 moles of CO2. Because for each CO2, we have one carbon. So the number of moles of carbon will be also equals to 0.0102 mole. Okay, so same thing, we're going to look for the number of moles of hydrogen, but we start with water. So we are 0.184 gram, and then for water, 80 gram per mole. And then we are 0.184 divided by 18. So we have 0.0102 mole of water. However, we have to find out the actual number of mole for individual hydrogen. So we are going to multiply this number by 2, the water by 2. Again, because for each water we have two oxygen. Sorry, we have two hydrogen. So for hydrogen we are 0.0204 moles, and then for our carbon we are 0.0102 moles. All right. So how about oxygen? How about oxygen? How can we find out oxygen? So from here, um, actually, I missed one of the information given. From here, we have 0.1595 gram of menthol being burned. So, I left that information. So it's corresponding to the mass of the menthol being burned. Okay, so we have the number of mole of carbon, and then we have the number of moles of our hydrogen, right? So we just have to convert that to mass. And then we use our total mass of our menthol to subtract the hydrogen and carbon. And then we have the remaining mass to be oxygen. And then from there, we can find the number of moles. Okay, so let's convert to the mass of carbon really quickly. So we have 0.0102 moles times 12. So for carbon, we will be 0.1224 gram. 0.124 gram. And then for mass of hydrogen, we're finding that from our number of mole and also molar mass. Because the molar mass of hydrogen is 1, so that's why we essentially same as the number is as the same as number of moles. Okay, so we are going to we know that we have the mass of carbon is 0.1224. Is given by we find by multiplied our number of moles by actually the number of moles over here times our molar mass and then for hydrogen it will be equals to 0.0204 gram, and the total mass will be 0.1595 gram. Okay, so the mass of oxygen will be equals to our 0.1595 gram minus 0.1224 minus 0.204, and then we have to find out the remaining mass. And the remaining mass is equal to 0.167, and this is essentially the mass of oxygen. Okay, so the number of mole of oxygen, we'll take this mass divided by 16, and then we should be able to find that is roughly around 0.00104 mole. Okay, so 0.00104 mole. Okay, so we are going to look at the molar ratio. So for carbon is 0.0102 mole. Hydrogen will be equal to 0.0204 moles. All right, so we have carbon, hydrogen, and oxygen. So we are going to set up a simplest ratio so we can find out the empirical formula. So let me erase some of the information that we don't need, and then we can proceed with the calculations. So right here, we have carbon to hydrogen. Sorry, carbon to hydrogen to oxygen. So we have 0.0102 to 0.0204 to 0.00104. Okay, so the next step, we're going to divide this ratio by the lowest number. So we have 1, 0.0204 divided by 0. So we have roughly around 20. And then we have 0.0102 divided by 0.00104. So we are roughly around 10. So we have C10, H20, and O1 to be our empirical formula. Okay, so for this empirical formula, we should be able to find that is equals to 156 gram per mole for this empirical formula. Okay, so what I did is that I'm going to just look at the molar ratio, and then I'm going to establish the simplest ratio, and then I can find the empirical formula of our menthol. And then I calculate the empirical formula. The molar mass of empirical formula is 1v6 gram per mole, and I'm going to look at, okay, how many multiple I have to multiply our empirical formula to give the molecular formula. As you can see that we calculate is 156 gram per mole, and also the molar mass is also roughly 156. So we can see that the multiple is roughly around 1. So essentially, for this case, the empirical formula also equals to the molecular formula, which will be equals to C10, H12, and O1.